So today we'll start first we'll do some revisions. Then after that we'll start with volcanoes, that volcanic mountain. So we studied about the fold mountains and also the block mountains we studied. So fold mountains, that mostly it happens due to the continental plate collision. Continental plate collision, or somewhere in divergence also it might happen. That divergence mostly it will occur in the block mountains part, that continent part, and also in the oceanic and continental collision also we'll see the formation of fold mountains. So in the oceanic continental, how we'll see? Let's suppose if this is oceanic plate and this is continental plate. So what will happen? Take this. Now this oceanic plate is denser, so it will subsidize under the continental plate. Then after it, what will happen? After the subduction, when it subducts, then this subduct part, what will be? It will go inside the mantle area, that near the astronosphere area. So there, due to that radioactive materials, you know that everything is in radioactive. All those materials are having the thermal differences. So there it will melt. This oceanic part will melt, and again after it will erupt from the continental part. From that smooth part where that part is weak, from there it will erupt. When it erupts, what will happen? When it erupts, if that is coming in the liquid shape, so it will start flowing to the longer distance. So that we will see that this type of eruptions, volcanic eruptions, we will see in the this longer like mid-oceanic ridges. And what will happen? Suppose if that is coming, see, it came like this and it got settled here, it cooled down and settled here. Again that collision took place. Again it came. Then from there again it erupted. See, here all solid materials will be there. So from inside that full pressure will be pushed upwards. So due to that all those particles upwards it will break into pieces. Then again it will flow. It won't travel too much. Again it will flow. Then again, so that means distance will be going on. So that will lead to the folding of the mountains. So that is fold mountain. Then in block mountains we study everything about the horst and graben. Block mountains we study about the horst, graben. What is this horst part? That rising part is horst part, and graben, that is in the slopy part, that is down part. And here we study that most of the block mountains formation takes place due to the tensional forces. See, due to the tensional forces. Actually, what happens? Block mountains formation takes place due to the compressive and tensional forces. But maximum of the block mountains formation takes place mostly due to the tensional forces. In the tensional forces, what happens? Tensional means this both plates. Suppose if this is a land, or you can say that is a part of a mountain. So now you can divide into three. Now suppose if tension is there, so tensional forces there means both plate will try to move away from their places when tensions are there. So that tensional forces means what? Both plate will try to move away. So during that time, what will happen? This down part, what will happen? This part will go this side, then this part half part will go this side. So during that time, what will happen? This part will become like this. Then this upper part, this part will be what? Like this, full. And then upper part, what will happen? This will come down, and this part will be like this. So this will lead to the formation of this. These both are block mountains. These both rising limbs are block mountains, and this is the rift valley. So in India also we have seen the examples, Vindhya and Satpura. In India we have the mountains, that is Vindhya and Satpura. See here, Vindhya and Satpura. Here we have lies in landscape. So here what happened? First we have the land formation here, block mountain. See, here we had, so due to tensional forces, what happened? This part got risen, both limbs, risen limbs got risen, and this part, middle part, went down. So in this middle part that went down, here what happens? This takes the formation of rift valley. This one takes the formation of rift valleys. So in this rift valley, what happens after sometimes if water is coming from somewhere, so through this way they'll make their path, because this is the rising path. So rising path, if their level is down, so how they will travel upwards. So they will mostly that water will travel downwards only. So this rift valley, through rift valley, we have the formation of rivers flowing there, and also we have the falls. So these block mountains, these both block mountains, we can see in the India. Example of Vindhya and Satpura, you can see here. So Vindhya here rising, again from here this is the rift valley through which Narmada river is following. So again here we have Satpura range. Then after that, downward there is a formation of rift valley. Then Tapti river is flowing. Then again that chain is there. So like that chain is there. So that is formation of block mountain. And all those rising limbs are the block mountains, and this falling limbs are the rift valleys. So this is all about the block mountains. And we saw, see, definition we have seen everything maximally, and this is taken from the Chrome. This written part, this I have taken from the Chrome. This just study one time. Otherwise, if you study from the notes also, or if you study from this all those parts, then everything will be clear. In block mountains, you know to study that much. Only some parts are there, and you must know about the. In block mountain, you must know about the transform fault. What is this transform fault? Also known as strike slip fault. Strike slip fault, or you can say it as lateral fault. Lateral fault also you can say. And in this also we have two types. So that I had shown in the notes. So just go through the notes also and study from there also about the lateral fault, because UPSC might go deep inside. So they might ask that left side of strike slip fault or which fault, or right side of strike slip fault or which fault. So like question also might be asked. So just that no, in the notes it is given. So go through the notes also. Okay. So this is all about block mountains and pole mountains. Everything we have studied in this. Now today we will study about the volcanic mountain. So in the volcanism, first we will see that how that volcano happens. See here, that volcano mostly that occurs when there is a collision between two places. Collision or divergence is between two places, and that both places are either oceanic or oceanic continent. Oceanic or oceanic continent. If plates are continental plates, then in these plates what will happen? Mostly the fold mountains will take place. Fold mountains or block mountains will take place. Block mountains what means? Fold mountains what? If these both plates are colliding, so in doing that what will happen? These both plates are of same density. So no maximum, no plates will subsidize. Means no plates will subduct. But what will happen when they collide? When they collide with each other, then materials here from the both parts and middle of that materials, that will start rising. Means what? If suppose these two are the plates, so this will start rising. So if that is folding, then it will rise. Then again it will rise in some. If again force is applied from the both the plates, again it will rise. Then again it will rise. So that is the fold mountains. And mostly the fold mountains are the highest. So that is the fold mountains. And block mountains, what we will see, that continental plates are colliding, and that formation of mountains are there. Then after that, in that we have the tensional forces. Tensional forces between the plates when we have, then we have the formation of block mountain. So in this continental plate, you must know that volcanism happens only when there is a presence of oceanic plate. If there is a presence of oceanic plate, then only volcanism process happens. And in that only volcano occurs. And in volcano, what happens? In volcano, when that volcano happens, it releases many things. Like rock particles already it releases. In that rock particles, we also have the minerals. We also have the minerals. In that minerals, we have mostly sulfur. Then we have acids. So that everything we'll study notes now in this class. So that sulfur acids, and due to volcano, if somewhere volcano occurs, then due to occurring of the volcano also we'll have the rain at that places, and that rain will be mostly the acid rain, because in this volcano we have the presence of sulfur and also we have the presence of hydrogen. So that sulfuric acid type, that there will be a rain, so there will be also the acid rain. So well, in the volcanism, what happens that if two plates are colliding or diverging, so in that what happens, if one plate is oceanic and other plate is continental, so what happens now, continental plate is less denser and oceanic plate is more denser, then what happens, this oceanic plate goes down. So there what happens, when that oceanic plate goes down, so these materials will melt, and that material will melt and they'll erupt from these places. From these places they will erupt. They won't erupt from this continental plate area here. So don't get mistaken. They erupt from these places, or they might erupt from these places. But from here, where that plate is lying, from there it won't erupt. So remember that one. So from here they erupt. So from here when they erupt, so in this you might have two types of volcano. That is, one is fissure type. Fissure type. Fissure means they are silent type. Fissure, silent type volcano. Fissure, silent type volcano will have. Then one more type of volcano will have, that is violent type. Conical violent type, we can say. Conical violent type volcano. Conical violent type volcano. So that we'll see in later part. Now see here, this lava types. So andesite or acidic or composite or stratovolcano lava. So in lava also we have two types of lava. One is acidic lava and one is basic lava. So that we'll see while we proceed through the class. So see here, these lavas are highly viscous with a high melting point, which they have high melting point, and inside the earth we have the radioactive materials, and they have the thermal differences, and also they are of the radioactive material is what they will be having the all those highest temperature and everything. So radioactive materials, they are used in the factories, like all those for burning in the nuclear factories. So there we are using. So here radioactive materials are present. So and also that all those in mantle we have the viscous material. So all those viscous materials have the high melting point. So they are the light colored. So this in the lava types we have the acidic. Now we are studying about the acidic. So acidic types, or you can say it is as andesite type or composite or stratovolcanic lava. So in the acidic type, see there will be the light color. So acid you might have studied. If it is how it is acidic, if it has the presence of silica, it has the presence of silica. See here, now in this example we will study. See here, acidic also we have, and also we have the basic type of lava. Okay, see here, in acidic type of lava we are studying in the previous classes when we are studying about the acidic rocks and igneous acidic rocks and basic rocks. So in that we had seen that it has the silica, highest number of silica content. So in acidic lava we have the 60% silica content, whereas if you study about the basic lava has the less silica content. So less silica content means you can say it as 40% or less than 40%. So it has the less silica content, basic lava, and acidic lava it has more silica content. So because of the silica content, it is highly viscous. Viscous means neither liquid nor solid. it will be like sticky type. So that type neither liquid nor solid. So that is acidic lava, not solid. So that is acidic lava. Then all those acidic lava are light in color. So all those, mostly if you see, most of the acids are light in color. So by that way also you can say that acidic lava are light in color, and they have the low density. Low density, how you can remember that? If you see the oceanic crust and continental crust. So oceanic crust we have the basalt, which is basic, and in continental crust we have the granite, which is acidic. So in this way you can remember that continental crust is the less, continental crust have the less density, and oceanic crust have the high density, higher than continental crust. So in that way you can remember that acidic lava, since continental crust is made of acidic rock, that is granite, so you can say that it has low density. So in this way you can remember that acidic lava also have the low density, and it has the presence of pyroclastic material. So pyroclastic material is what? Small matters, small particles, that broken rock fragments, that is known as pyroclastic materials. That way in notes it is written all the definition. So there we'll see. So they have the small particles, and here mostly all this acidic lava comes in when the convergence is happening. So when that convergence is happening, that convergence plate boundary taking place, there only you have the mostly acidic type of lava. So how you can say, see, convergence is like two places are colliding and this one is subducting. So in that way what will happen? Here we will have the melting point, all this submarine will melt. So again from here what will happen? Now see, this is the crust. So in this crust what will happen? Now this is solid one. So for breaking this one we need high pressure, and already high temperature we have. So that what will happen, that due to high temperature pressure inside that will push it as upwards. So when it will pushing it in full pressure and high temperature, so this particle is there, and suddenly they will be throwing out. So it will break and it will send all those parts here and there. So in that way what will happen? In that way volcano will take place. So in that it will just come up and it will settle down in the near places, because we have in this one we have mostly all those broken parts we have. So solid parts we have, and also we have the viscous parts. So it won't flow to that much greater distance. So it will be settling down here. Then again what happens? Again if convergence is there, then again from here, now this, after some years this part will become solid one. Then again from through this pipe, again this volcano erupt. So when it erupts, so again it has to break this part. So again this that parts will break into a smaller parts, that a smaller rocky parts. So this part is known as pyroclastic material. So okay, and this we have in the convergence plate. So again they will be settling down. So again if it erupt, again you will have the settling down. So in that way it is forming the strata. In that way it is forming the layers. So that is stratovolcano. So in further we will study that what is known as stratovolcano. So stratum is what? Layers you can see. So we will have the formation of layers like this. So in that way that is stratovolcano. And in acidic we have the low density, and it erupts like you can say it will go to the higher, it will go to the height type. So it will go height type, but then it will fall down. So that's why it's not traveling to the longer distance. Just it will fall down to nearby. It will travel to the only to the near shape, and it will take the shape of shape. Now these two are the place. So it will be erupting, and that convection current, that mostly that inside Earth we have the convection current, so that all materials will burn, and through that convergence it will be erupting. So what will happen? This will just going up, and then it will be falling down only to the some distance. So in that way layers also will be forming. So in that way, and it will take the shape of cone. So this type of volcano also known as conical volcano. So remember this also. and also is conical volcano, also known as. Then after that, this is also since it is forming strata, so also it is known as stratovolcano, and also we study about the andestic volcano. So here see andestic volcano. So this is also known as the andestic volcano. So in this, what happens? See, inside the earth we have and see, and in this what happens? In this volcano comes up mostly from the central well. Now this will be formed at the pipe, and this pipe is known as vent. That volcanic pipe, it will be formed, and this pipe is known as vent. And now these materials will be settling down here. Then again it will go, it will form layers, and these materials will be settling down here. So if any time volcano occurs in these places, so now this is the escaping parts here. So they will escape from this place only. So this place is known as the central vent. So that we have in the acidic lava type. We have the central vent. So remember that central vent, and in a basic we have the fissure vent. Fissure vent. So that also we will study. So see here. Now here, so solidified, it will solidify rapidly since it has the solid parts and also the viscous parts. So that will be like clay matter. So that it will have, so it will solidify fastly. So and also we saw that it will not travel to the longer distance. So and conical we have studied, and eruption we have studied. So and this will be explosive. See, we have studied here that these two places will be colliding. So now central vent will be here. So first it will form layer. Then again after some years this part will become solid. Then again this layer comes. So when that layer comes again, so that time what will happen? Now to break these parts, we'll have high pressure from the downwards and high temperature. So that time what will happen? This will explode. So this is explosive lava. So this will explode. Then only that lava, that magma inside the earth will be able to come out. So and in this, remember one difference between lava and magma. Lava means what? First we'll see magma. Magma is what? When that all those particles are in the liquid state inside the earth, that volcanic parts, that is in liquid state, that rock parts, that is liquid in state, or you can say it has molten in a state inside the earth. Inside the earth we have the magma. Inside the earth, that is known as magma. And when it comes out of the earth, so out of the earth, that is known as lava. So remember this difference. Okay. So in this acidic lava, mostly we have the mountains formations. So in this we can say we have the mountains formation high types. So like we have the mountains formation in the acidic lava. And in basic lava we'll have, see in basic lava also mountain formation is there. In this also we have some other types of formation also. You see. So okay, here we'll try and see. So basic lava means what? These two places colliding. So that basic lava will have mostly in the convergence or divergence. So only sometimes we have the in oceanic convergence, but mostly we have the divergence. So okay. So now when that divergence is there, in see, don't study it as continental plate. See, continental plate they will start folding, but in oceanic plate what will happen? Why it will start folding? Because they have the thicker type. Where this oceanic plate, they are in thinner type. Well, they have the size only 0 to 5 kilometer. They extend only 0 to 5 kilometer. But where it's continental plates, they extend to like 10 to 70 to 90 kilometer. So like they extend. So in this oceanic plates, what's happened? They have the higher density. So they have the higher density, but in that also okay, they have the same density. But here we study that in that continental ocean, that continent have the less density. So in oceanic plate, what happens? That particles will get subduction. In the oceanic plates, we have the subduction, but in continent plates, we don't have the subduction. We have the folding. So in oceanic plates, the subduction will take place. So when that volcano formation is taking place, when volcano occurs, so in this what happens? Oceanic, in a ocean we have the basic rock. So that we are studying in rocks part, that in ocean we have the basic rock, and it is made up of sima, silicon and magnesium. So here we have the basic rocks. So in this basic rocks, what happens here? Now this is in the molten state. So mostly now due to high temperature in the oceans, so and high pressures, so that is forming all those viscous liquid, viscous part into the liquid. And when that this part is broken, they will be mostly highly in the liquid. Where this acidic lava, when they erupt, they will be in the viscous state. In acidic lava, they will be in the viscous state. Where this basic lava, when they erupt, they will be in the liquid state. So they will be in the liquid states of matter. So in that, what will happen? Now these two are in the this oceanic place. When it erupts, these are in the liquid state. So what will happen now? Since it is in liquid, so if it comes above the earth, so it will start flowing. It will liquid. It is in liquid means it will start flowing. And viscous means it is somewhat solid or it is somewhat liquid. You can say that. So that time what will happen? It will settle down there itself, and it will cool down fastly there itself. But whereas since these are in liquid state and they have the high temperature, so what will happen? That liquid means what? If you pour water here, so it will flow to the nearby surface area like. So that this also will start flowing onto the both sides. So they will flow to the maximum distance. So in that way they will be flowing. Then again, if it is erupting, then again it will be flowing. So again they will be forming that layers also, but they will be flowing like this. So they'll take the form of shape of sealed type. So this is also known as sealed volcano. So this is also known as sealed lava or sealed volcano. This is also known as sealed volcano. So that's what we saw here. So and basic lava, we saw that it has less silica content, and it consists of, since basic lava means oceanic place basalt area. So basic lava consists of mostly basaltic rocks. And we studied that this oceanic crust is in mantle area, that is sima. So here we have the mafic mantle. Here we have the mafic magma. That magma we have in the mafic state. Where in this acidic we have the felsic state. This is as iron and silicon. And here we have the magnesium and this iron and carbon. So here we have the in the magma state of matter, where in this we have the in the viscous. So in this now what is happening? So and this will be the hottest lava. Basic lava that we saw that it will have the high temperature. So this will be the hottest lava. So they'll be in the form of mostly in the liquid form. So they will flow to the longer distance. And since they are hottest, so they'll be in the fluid and they'll be the less viscous. So less viscous we are studying. And these will take place mostly in the divergent plate bonding. See, divergent plate bonding. Divergence means what? We study that in when you have this convection current is coming like this. So again here also we have the convection current lies in circular way, convection current. So now these two parts, these falling limbs, they are converging with each other. So in this type we will have mostly in the acidic type, acidic lava type. And now here what is happening? That divergence is taking place. So that all those basic lava is taking place mostly in the divergence plate bonding, and they will flowing to the longer distances. When this acidic lava, this convection current, see now this convection current is going down, and from here we have the high temperature and that particles have melted. So from if it is coming up, it will have the high pressure. So it will travel longer height. Whereas in this place, that it will be coming in the liquid state itself, and also they have to travel only to the lesser distance, and they need to place only some less pressure. So since they are in liquid state, so they flow to the longer distances. So that is the basic lava. So we saw less viscous and in divergent plate boundary, we saw that mid-oceanic regions takes place. Mid-oceanic regions formation takes place. So two ocean plates are colliding. Now in divergence state, now this what will happen if volcano comes, it will travelise. Then again when it erupts, so this place will move to this side. So again it will travelise. So here again we will have the formation. So like this it will be both sides, it will be traveling to the longer distance and they will be forming the chains. So that's why we will see the longest mountain chains, that is mid-oceanic ridges, that is in the Atlantic Ocean. Then from there it will be traveling towards the Indian Ocean, it will go into Pacific. So that mid-oceanic regions, so that is the formation of ocean-ocean continent convergence. Sorry, ocean-ocean convergence, not continent, ocean-ocean convergence. So in this basic lava, we have the mid-oceanic regions. So this is the example. And this basic lava, we have the formation of plain or plateaus. So plain or plateau is what? See, now this will be forming lies here. So mostly it won't have that much height. So now they are not having that much height. So what will happen? Formation of plain will be taking place. Then also formation of plateau will be taking place. Plateau is there in the lesser height only. So formation of plateau also will be taking place. So this is all about the basic lava. Basic lava is their basaltic lava. Then they have the less silica content less than the 40%. Then they are mafic magma. Then we have the hottest lava. Basic lava is the hottest lava. They flow in the fluid state and they are less viscous and they lead to the formation. All those basic lava takes place in the divergent plate boundary and they lead to the formation of mid-oceanic ridges, plains and plateaus. So this is all about acidic and basic lava. So see here, in acid lava, these lava are highly viscous with high melting point. They are light color of low density and have high percentage of silica. They flow slowly and seldom travel far before solidifying. So they won't travel that much. Then anistic lava flow occurs mostly along the destructive boundary. So destructive boundary means what? Convergent boundaries. So there we have the formation of acidic lava. Then we have the basic lava. So they are the hottest lava, about like 1000 degrees Celsius. They are highly fluid. They are dark colored. They are rich in iron and magnesium but poor in silica. They flow out of volcanic vent. So they flow out of this basic lava. They flow out of volcanic vent and are not very explosive. So in acid we saw that we have to apply high pressure. So due to that, that acidity is explosive. But well, this basic is not explosive. Then sill type of lava, that we saw that layers is taking place. So it is forming like a sill. So that is sill type of lava. So sill type of flow is common along the constructive boundary, that is divergent plate boundary. So sill type of lava is common in this area. So that is about the acidic lava and basic lava. Then we have the volcanic landforms. Now that all those lavas will be flowing and coming out, then after that we'll have the formation of volcanic landforms. Now that landforms might be in the mountain type, or we might have in the ridge type, or we might have in the plain type or plateau type. So that landform formation will take place. So what are these volcanic landforms? So rocks formed by cooling of magma within the crust are called plutonic rocks. So plutonic, we studied that igneous rocks. So rocks formed by cooling of lava above the surface are called as igneous rocks. Then in general, the term igneous rocks is used to refer all rocks of volcanic origin. So igneous rock means what? They are the primary rocks. So if we have that volcanic origin, if we have that rock lava coming down from the earth, from inside the earth, and it is cooling down on the surface of the earth, then only we have the formation of rocks. So that rocks are known as igneous rocks. Then after that it gets weathered or denuded. Then after that we have the sedimentary, then metamorphic. So igneous rocks are primary rocks. So rocks They are formed by the cooling lava above the Earth's surface. So in this we have the extrusive volcanic landforms and also intrusive volcanic landforms. So extrusive landforms we all have seen. Intrusive also we have seen in the previous classes, that all those laccolith, lopolith, batholith, all those things we have seen in the previous classes. They are the intrusive land. See, so conical vent. Conical vent we have studied that when two plates are colliding and we have the convergence. We have the convergence. So in this convergence, what happens? It applies more pressure and it comes less. Then this pipe will be what? In a straight manner, and this lava will be flowing. Then again from this pipe only lava will come out and again it will be flowing. So this type of pipe known as conical vent. See, this is known as vent. This pipe is known as vent, and since now after it is going up and forming the shape of cone, so this is conical vent. So a conical vent is a narrow cylindrical vent through which magma flows out violently. So in acidic only we saw that that explosive takes violently. So in that we have the formation of conical type of volcanoes. So that is in through which that magma is coming, that is conical vent. Conical vents are common in anestic volcanism. So that is composite or stratovolcano. So composite we saw that did not say, and that layer forming rocks are also known as composite volcanic rocks, that in which we have that conical vent. So if we have the conical vent type, so that is anestic lava. So that is will be taking place due to the formation of anestic lava, and also that it will sitting down layer. So that particular that landform is known as composite volcano, or you can say it as a stratovolcano. So they are given the some other name, and also you can say the conical. You can say it as cinder cone volcano. So see here we have the formation of also composite, and already we say that we have the formation of cones. So this is about the conical vent, and mostly example you can say that Mount Fujiyama, that is in the Japan. So that is a conical, that formation took place, that volcanic action took place from the conical vent. Then extrusive volcanic landforms. So in extrusive we have the conical vent and fissure vent. So fissure vent where we have in the basic lava, where that lava flowing, it is coming out. So there it is flowing to a longer distance, and that lava when it's coming up, it is in the liquidation. They are flowing to a longer distance. So in this that vent we have, that is only to the short, that vent is only shorter, only they have the less height. So that vent is known as the fissure vent, and conical vent that we saw in the acidic lava. So we have the formation of conical vent, that it will be of height. So in that conical vent, that land formation is known as a stratovolcano, and in this fissure type we have the formation of sealed volcano. So this is example of conical vent and sealed, and this is the extrusive volcanic landform. So what is fissure vent? A fissure vent is a narrow linear volcanic vent. Fissure vents are common in basaltic volcanism, seal type volcanoes. So they are common in the basalt type. Okay. So now composite type of volcano, that we saw that mostly this type of volcano takes place in the acidic lava. So remember that acid name, one more name, that is anestic lava, and it is coming many places. So remember that acidic also known as the anestic lava. So that anestic lava accumulated in the vicinity of the vent openings, leading to the formation of layers, and this makes the mounds appears as a composite volcano. So remember this name: composite volcano, stratovolcano, cinder volcano, and we have sealed volcano. So remember all these names, because from these names only question came. I think so 23 part 1 paper 1 or 2022 paper 2. In that questions came about this one. So remember all those volcano names and their definitions. That everything is there, even these slides also, and also in the notes. So I studied from that also. So okay, then in this composite type, that is acidic type, also we have the Mount Stromboli, that is the lighthouse of the Mediterranean Sea. Okay, yesterday we saw about the Mount Etna, Mount Vesuvius. Yesterday we saw about Mount Etna, Mount Vesuvius. So where are these? Mount Stromboli. Where are these? Mount Etna, Mount Vesuvius, and Mount Stromboli. All these three are in the Italy. So Italy, now see, if this is the world where size you can consider, and this is here in middle we have the Mediterranean Sea fluid, and then here downwards we have the Africa part. We have the Africa part. Mediterranean Sea here it is flowing. Then we have the Asia lines, and then again from here one sea is flowing, that is Dead Sea. Dead Sea. And remember in this also, now in this, remember this one, here we have the Suez Canal. So if question come that Suez Canal is between which two sea, then this is Red Sea. Okay, Red Sea. Here we have the Indian Ocean. Indian Ocean here we have the Red Sea, and here this side we have the Mediterranean Sea. Mediterranean Sea. So remember this name. So here we have the Suez Canal. So remember, if question comes that Suez Canal is between which two ocean or which two sea, so between the Mediterranean Sea and the Red Sea. And here in this Europe part, here we have the Italy part. So in this Mediterranean Sea, now in this we also have the oceanic plate, and here upwards in the Europe part we have the continental plate. So here we have the Italy, all those Mount Etna, Mount Vesuvius, and Stromboli. So this Stromboli, here what happened, maximum times eruption will be going on, volcanic eruption will be going on. So due to that volcanic eruptions, it is known as the lighthouse of the Mediterranean. So in time volcanic will be going on is what? That high amount of temperature will be there. So there will be some light in that lava. That lava will be glowing. So there will be diving plants. So due to that you can see that nearby things will be, even that we can see from the farther distance. So you will say, okay, from there some volcanic eruption is taking place. So that's why it is known as the lighthouse of the Mediterranean Sea. Then Mount Vesuvius, that is in Italy, we saw. Then Mount Fujiyama, that is in Japan. That is also examples of composite type volcanic landform. So composite type is what? That lava is of acidic type. Okay. Now what is crater? Crater is what? See here. When we have the and crater formation takes place only in the acidic lava type. Okay. When we have the violent explosive, so there we have the formation of crater. Now we have the convergence, and these plates are colliding. Okay. So here these are melting, then it is coming to a pipe, and it is settled on a shorter distance. Then again it is settled on a shorter distance. Then again it is settled on a shorter distance. So that high pressure will be coming out. Then this, when it will, that blockage will be there. Then again from here that high pressure is coming, means what? This will burst into smaller parts. So all these rock particles from here, that they will be broken into small parts. So all these broken rock particles, they are known as the pyroclastic rock. Pyroclastic rock. So pyroclastic rock means what? Smaller rock fragments. So that will be in notes, that is there. So you can study it from there also. So they'll be forming the layers. So this is also known as stratovolcano, and a stratovolcano we have in the acidic lava. So okay. So in this, what will be happening? It will be flowing through upper distance. So now this pipe, in this pipe, what it will be again, if it erupts here, then again here it will be the round shape. So this round shape, and this is forming, like you can say it as a circle. So this is known as the crater. This is known as the crater. See here what is happening. Now this, why we have like this, like we have, like we can say it as pond type. Why we have like this, some depth is there? Because see, from here explosive from here. Now this is breaking suddenly and explosion is happening. So when explosion is happening, and they are mostly in the they are not in the liquid shape, they are in the viscous or solid shape. So that materials will burst. Then and then again they'll fall down at the same place. That materials rock particles, if they are in heavy weight, so they'll fall down at the same place. And if they're not heavy weight, they'll just fly somewhere. So like that will be happening. So in that, when that fall down somewhere, so then this part will become lies in shape. So daily pressure means this part will go down because it is now it has not become fully solid. They are in the viscous state only, or liquid state. So this will go down. So that will lead to the formation of this type of like pondy area. So this is known as the crater. So this is crater. Now crater formation happens. So this is crater. And what happens if we have then, we know that when volcano takes place, so from the volcano that many particles comes out, and many acid also comes out, many elements also comes out, so that they mix with the air and they become into the vapor and they result into the rain. When that cloud particles, see inside the rain also we have that water droplets, they'll be in the smaller shape. When this takes place, so they'll become in bigger in shape, that all materials will be joining. They'll become in bigger in state, and also they'll be having high temperature. So what? This will lead into the rainy, that cloudy will become turn into the rainy time. So rain will happen. So when that rain happens, so in this what will happen? Now this has become in this circle type, like this part has gone down. So here what will this water will settle down here. So when the water settles down here, then this type of formation are known as crater lake. This type of formation are known as crater lakes. And crater lakes does not happen only due to this volcanic eruption. Sometimes what happens, now this mountain is a volcanic state in the conical shape. So what happens if this water is falling down, so this is crater lake. What happens sometimes, see, all meteors are not burning in the mesosphere. So that leftover meteors, if they are falling in the land, so mostly they are falling in all those land area, that volcanic area. So when they fall down, they'll be pressing, they'll be having the pressure. So they'll press. So what will happen? This upper part will break, and because of that huge amount of pressure, then again it will take the shape of this type of land on the volcanic. So due to meteors impact also, we have the formation of crater lake, and also when we have the raining season, or when we have the rain, so that time that water gets fill here, so that will result in the formation of lake. So that type of lake are known as crater lake. And in India we have only crater lake, that is in Maharashtra, that is Lonar lake. So remember this example. This have come in the exam also. So remember this example. This is crater lake, and this is due to the meteor's impact. This is due to the meteor's impact. So remember this. Okay. This is not due to the formation of that rock particles falling down. This is not due to the volcanic eruption that rock particles falling down. This is due to the meteor's impact. So remember about the Lonar lake, that is in Maharashtra. So remember that one. See, crater. What is crater? When water from rain or melted snow gets accumulated in the crater, so that becomes the crater lake. So crater, we have the Mount Fujiwara, that is in Japan. There we have the formation of crater lake. Okay. Now what is caldera? So this caldera land formation also takes place in the acidic lava type. See what happens? This lava is flowing, and here what is happening? So in caldera what happens? In way that it is same type like crater only. What will happen now? This here in this layer it will be forming taking the shape. So what will happen? That this part all these parts here, that all it will be solidified. So it will take the formation of larger type. That see, crater lakes are in smaller size. Where in this caldera, what will happen? It will be in larger size. So larger shape. So in that, what will happen? That larger shape, again that water is falling down, that will be taking the formation of lakes. So that is caldera. So crater is a smaller in size, and similar type only we have the caldera, that is in bigger in size. So that is caldera. And in this we have the important lake that is in Indonesia, that is Lake Toba. So see, what is caldera? The volcanic material above the chamber collapse into the empty magma chamber, and the collapsed surface appears like a large cauldron like hollow. So that is becoming the larger shape, like this a top shape. So that is caldera. When water from rain or melted snow gets accumulated in the caldera, it becomes a caldera lake. So in that example, we can see it as the Lake Toba. So see, caldera lakes are also known as the crater lakes. So they are the same type of crater. Only thing is that caldera are larger in size. So Lake Toba, Indonesia, formed after the super volcanic eruption around 75,000 years ago. So that is the largest crater lake in the world. So this is the largest crater lake in the world. Okay. Now we will study about the feature type of basaltic landforms. That is a basic landform. So basaltic magma erupts for a long time, spreading over a vast area. So they'll be erupting. They'll be keep on erupting. So they'll erupt for a long time. They'll erupt for a long time, and long time they'll be erupting, and so they'll be having high temperature, and also they are in the liquid state. So they'll be flowing to the higher distance, and this vent will have the smaller height. So this is known as the fissure vent. In basic only we have the fissure vent. In basic we have the fissure vent, and this will be like a liquid state, means it will always running, it will be flowing. So in this area, what happened? Basaltic magma erupts for a long time, spreading over a vast area. So you see, in this only, what will happen? Now this layer formation will be taking place. It will be settling down here. Then again that comes out. It will be settling down. Again it will flow. Then again it comes out. So light, what happens? No, just it gets settling down. So it takes the formation of, you can say that some highest also. And see, highest mountain, if we not include the ocean, see, in the world, what we are calculating, that height of mountains or something, if we are calculating from the sea level, or you can say it as ocean level. We are calculating their height from the sea level. But where is that example? If you see, we have the two mountains, that is Mauna Loa and Mauna Kea. These two mountains, they have the highest height. If we do not include this sea level, so if we do not include the sea level, they have the highest height. They have the height of 10,205 meters. So that Mauna Kea, that mountain is, if we will not include the sea level, see, inside the water, that body is 6,000 meters, and upper one we have the 4,205 meters. So that's why it is included, only this side is included. But where if we exclude the ocean or sea level, then it has the height of 10,205 meters. And where this highest peak, Mount Everest, have only 8,848 meters. So if we exclude that water level, then it will be the highest mountain of the world. So in example, basaltic type, we have the Siberian traps, Deccan traps, that is also known as plateau, snake basin, island. So in this basaltic, we study that this takes the formation of layers. So these layers take the shape of shield type. So this is, in this basic also we have the shield formation of shield volcano. Then you can see a shield type. Shield type, you can see that the Hawaiian volcanoes. So these are the mostly example. They are basaltic in lava. And this Hawaiian volcanoes only we have the Mauna Loa and Mauna Kea. So this Mauna Loa is still erupting. That is active shield volcano. So if it is erupting, means that is active, and if it is not erupting, it is dormant. And if that volcano is extincting day by day, that is known as the extinct volcano. So that also remember. And if the volcano is silent for longer time, then that volcano is known as the dormant volcano. And if the volcano is erupting day by day, so that is active volcano. So in that we have the active silt formation, and in monarch we have the dormant silt formation. And see here, when we have the conical shaped type volcanic eruption, then we have the conical shaped type volcanic eruption. What happens? Sometimes if the weaker part is this side, so lava comes out from this part also. Lava comes out from this part also, and they settle down and they forms a mountains here. So these type of volcanoes are known as parasitic. So parasitic, like in biology, you might have studied that about lichens or some other like cuscuta, that type of plant. That if tree is here, so on that tree they are growing and they are feeding themselves. So they are growing on the tree and they are feeding from that tree. So in this volcano also, that they have the volcano from the side parts. So they have the lava from the side part and they form here, inside they form the mountain. So that is known as the parasitic cone, or you can say that when that mountain formation takes place, so that is parasitic mountain. So in parasitic mountain, one very most example we have, that is Mount Shasta. Mount Shasta. That is, if you see in that Rockies in the North America, there we have the Mount Shasta. So remember this Mount Shasta name. This is the parasitic mountain. So here parasitic cone shape landform formation takes place. Then composite type of volcano we have seen. Okay, composite type we have seen. Then crater lake, lunar lake. That due to the meteor impact that took place during the Pleistocene epoch. Means what this is in our recent year. So and that lunar lake in the Bulhana district of Maharashtra. Then cinder cone. In that crater type only we have the cinder cone formation. See, it will forming the conical side. So in this what will happen? One side is the steep circular. So that steep circular lies, that shape is known as the cinder. That one side will have the somewhat steep side. Means what? See, now when we have the cone type formation, now this is becoming the slopy type. What in the cinder cone type, what will happen? That one side will be like broken, and that will be the steep side. Means what? If you go there, means it will fall down. And here means what? Slopy type means what? You can just roll and you can come like that. And this steep side means it will fall down. So that type of conical volcano is known as the cinder cone. So remember this example. A cinder cone is a steep circular or oval-shaped hill or loose pyroclastic fragments that have been built around the volcanic vent. Then pseudo volcanic features. Pseudo means what? They appear like as a volcanic features, but they have not erupted due to the volcanogen. So that is pseudo volcanic feature. That meteorite crater we have studied, that is due to the high pressure coming. So that is also the example of pseudo volcanic. Then salt plugs. That what happens now, due to capillary action, we are taking out the water. Now this is the water table. We are taking out the water to irrigate. So what is happening? From here, when that water table is going down, so down in the soil we have the salt mixture also. So that salt mixtures, they are coming up and they are setting here lies. So that happens in the mountains area only mostly. So that salt is coming up, settling lies. And what is happening? Now here what is happening, that water in the upper part, they are evaporating and the salt is being remained at that place only. So that crystallization are taking place after some time. So that crystallization leading into the cracking in that all those places. So that due to the crystallization, it looks like that having taken place as as volcanic eruption, but that is due to the salt crystals formation there. So that is the salt plugs. So pseudo volcanic features are certain topographic features that resemble volcanic forms but are of non-volcanic. So pseudo volcanic was there appear as a volcanic landforms, but they are non-volcanic. And that we have the craters, salt plugs, and mud volcanoes. Then salt structures are mud volcano we will study in the later stage. Salt structures are impermeable. So see, salt we saw that is impermeable. That means what? Through that we can't send water, and that water will settle down there, and that water evaporates. So there salt crystallization takes place and can lead to the formation of a stratigraphic trap. So that impermeable layer capable of retaining hydrocarbon. So a structural traps in contrast are cracks in faults and holes. So that can retain hydrocarbon. So that will lead to formation of faults and holes. So that will appear as a like volcanic, but they are not volcanic land. So this is about that. So okay. So that was about that one, and one volcano we study the later stage. See, in intrusive landform we study about all those batholith, facholith, lopolith, lacolith, seal dike that we have studied. See, in extrusive we have the cinder cone, composite volcano, sill volcano that we studied there in the previous slides we studied. So they are the extrusive landform. So remember this one. Then see here that if that is in this saucer shape, then this is known as lopolith, and if it is anticline syncline type, it is facholith, and if it is in dome shape, then that is lacolith, dome shape. Then in this vertical, it is in a dike. Then horizontal, it is sitting down, it is seal, and it is in land, it is spreading to a longer distance. That is batholith. So that we are seeing in the previous classes and also in the previous slides also, and that is given the notes also, all those about those things. So just a study. So that's everything that is mentioned, that only that horizontal bodies are seals. So study that one. So dikes, that everything is given, and that dikes types of formation that takes place mostly in the western Maharashtra area, and that dikes formation takes place mostly in the Deccan Tribe area. Remember that one also. Then lacolith, in the Karnataka plateau you have the formation of lacolith. So it will be like forming a dome shaped intrusive bodies connected by pipe like conduct from the below. So that is lacolith. Then we have the batholith. The batholith we studied, these are the large granitic rock bodies formed due to the solidification of hot magma inside the earth, and they will be spreading to the longer distance in that down shape only. So batholiths form the core of huge mountains. So they form the, like you can say that if you are building something, so that base, in the base we are putting some concrete and everything. So light shape it is. The batholith is of that type. That is inside the earth crust. Then this is what mud volcano. So see, mud volcano, see, we will study it. Some mud volcanoes entirely are non-volcanic origin occur near oil fields. So see, oil fields that where methane and other volatile hydrocarbon gases mix with mud force their way upwards. So in oil fields, what happens? We are extracting oils from some places. So nearby these oil fields, what happens? Now in this oil we have the methane and also we have the hydrocarbons. So in that nearby area also it will be having the methane and hydrocarbons. So what will happen? Due to that, these earth parts, they'll be having like there'll be some cracks and getting better. Then what will happen? Suddenly due to that pressure, due to presence of methane and volatile hydrocarbons, that will rise up that nearby area, and they will take the formation of, like you can say, dome shape or like circular shape. So like shape they will take place. So that type of shape, and they will appear like a volcanic land, but they are not due to the volcanoes. They are due to the presence of methane and other volatile hydrocarbon gases. So that takes the shape of dome shape. So that is mud volcanoes. So this is about the mud volcanoes. Then Stromboli volcano, that is lighthouse material that we have seen, that is explosive. In that we have the acidic. So this is about the Mount Vesuvius. So no need to study everything, but you must know that is in Italy and that is a stratovolcano. Then all these mountains examples are given. Mount Tambora, all examples are given. And this, see, one thing we forgot, mantle plumes. This is what, see, now volcanic eruption is taking place from this place. This material having one oceanic continent collision, this material has been burnt, and here what is happening? Volcanic eruption is taking place from this place. What happens? Okay, if there is something like heavy materials on this area, what happens suddenly? Some volcanic eruptions takes from opposite of this area. So they'll come opposite of this area and they might erupt from this place or erupt from this place. So when they erupt from this place and they take the volcanic landforms, so that type of is known as mantle plumes. So this is known as mantle plumes. So remember that. A mantle plume is a convection of abnormally hot rock. So this is abnormally hot rock. So remember this. This is now, see, it should appear from this way only, but it is appearing as a abnormal. So it is coming from this side. So this is mantle plume. So remember this one. So mantle plumes seems to be relatively, mantle plumes are tries to form a core mantle boundary. So they are trying to form a core mantle boundary. So you can see the diagram of mantle plume. So this is about the mantle plumes. So see, on the continents, mantle plumes have been responsible for the excessive accumulation of flood basalt. So what they are appearing for the opposite side, they are appearing abnormally. So the basaltic magma may then erupt onto the surface through a series of fissures, giving rise to a large igneous provinces. So that is the mantle plume. So remember that one. Remember that a keyword, that is abnormal. So if they are acting it as abnormally, so that is mantle plume. So remember this keyword. Then igneous provinces, that all those are mentioned here. You can go through the map and you can study all these things. And geysers and hot spring move forward. See, about the Icelandic arc we studied. Icelandic arc I have said you that in volcanic, in this landform, basaltic type of landform, what is happening? This is settling down. Then again, when that plate movements are there, then this part is coming here. Then again here there is a formation of landform here. Again this part is coming here. So they are taking the shape of landform inside the ocean area, inside the sea. So inside the sea, if they are taking place, and they are in the center and it is surrounded by the water. So that is the island or archipelago. So there, and this is taking the like series. So that is Icelandic arc. So that is about the Icelandic arc. Now we will study about the geysers and hot springs. So what is geysers? Geysers, what happens is from the down of the earth. See that volcano have been erupted from that places. So what happened, that volcano now, instead of eruption of volcanoes, what is happening when that land formation have taken place? Instead of volcano, what is happening? From the down, hot waters are coming out of the earth. Hot waters. That not volcano is coming out, hot waters are coming out. So when that hot waters are coming out and they are having the high pressure, is what they will be flowing like you can say that pressure type means what, that materials used for the car washing, that in that we have the high pressure to wash the car or wash the vehicles. So there you can say that high pressure. So it will be flowing and it will be flowing to the height type. So that is the geysers. So they are known as the geysers. And what is hot spring? Hot spring also are the same time, but same type only. Hot water only will coming out, but only thing that they will have only little means what, they won't be flowing to the that much height in the as geysers. They'll be coming out just up to sometimes, and they'll be just sprinkling nearby that area. So they are the hot springs. So almost all the world geysers are confined to three major areas, that is Ireland, New Zealand, and Yellowstone National Park. That we studied, that Yellowstone National Park of USA is nearby which state, that we have seen in the study note. So remember that one. Then type of volcano: active, dormant, extinct. So active means what? It is erupting every time fairly or frequently. And dormant means what? Eruption has not occurred regularly or recently. They are the dormant. So and extinct means eruption has been recorded in the historic times. This is what like in ancient history, like that it has taken place and it has not erupted yet. So that is extinct volcano. So this barren land, that is the active volcano in the Andaman and Nicobar area. Then Mount Kenya, that is extinct stratovolcano. So all these examples are there. So I study everything. Then Mount Kilimanjaro, they are the dormant. So remember that all those volcanic names and there these type of volcanoes. You can see all those distribution of earthquakes and volcanoes. So mostly volcanoes we have in the Pacific area because there are only many places are there. So I study about that one also. So all these examples are there. So I study all those names and everything. Just study one time. Then the 5 countries with the most volcanoes, they are USA, Indonesia, Ireland, Japan. So remember these names. Then I have mentioned in the map also. Just go through for your clear understanding. Then volcanoes, silt we studied, composite we studied, caldera we studied. Then flood basalt is what? That is flowing on the earth, that basaltic rocks that they are flowing. So that is the flood basalt. They are flowing through the longer distance. And ocean ridge volcanoes we have studied. Then cinder cones we have studied, composite volcano we studied. So all these we have studied, and all those examples already I have given. All these we have seen, and all this physical map of all the continents I have mentioned in this slide. So just go through that and study. See, in Australia, we have only one mountain, that is Great Dividing. So study about that one also. So just you must know the location. So this is all about the volcanoes, volcanic mountains. So this is all about the volcanic landforms. So and all landforms, all those mountains are mentioned in the map for your understanding purpose. And also if you have some doubt, then you can go to the Google and you can search about that particular mountain so that you have the understanding of it. So okay, this is all about the volcanic landforms. So any doubt in it, you can ask for me. Anyone, any doubt in this one? See, and in the notes also that all those important definitions, everything are written. Everything are written. So just go to the notes also so that you have the clear understanding. See, everything are there, craters, everything, and some extra examples are also there. And remember that all those extra examples, because that is like application based questions. And UPSC mostly they used to ask the application based questions. So study all those notes also. So any doubt in this one, you can ask. Anyone, any doubt in this? Okay. So that's all for today. And I'll share these notes to you all personally. First, let me take the screenshot of it. All they are present in this class. Okay. All these students will get the notes. I'll send them personally. So any doubts you can ask me anytime. So that's all for today. So we'll finish up with this one. And so study all those notes and study all those examples and all those application type questions. So that's all for today. So we are ending our class here. Again, we'll meet tomorrow if I am free. If I am not free, I'll message in the. So that's all. Thank you. Bye bye. We'll meet again tomorrow if possible. So okay, you may leave now.